Hey everybody, in this video in the AWS Terraform series, we're going to continue building out our infrastructure and building some routes. So at this point, it might make sense to start separating out some of this stuff, right? So you could have a vpc.tf. You may not want to put it all in the same one. So like what I can do right now is I can just add maybe a comment up here, VPC, and then like these are subnets. So I mean, it depends on what we want to do. We could separate this out for prod. We could separate it out for, you know, whatever we need to do. But it may make sense to start doing that as this gets larger and, you know, it gets more confusing. Elastic IP, there we build the NAT gateway. NAT gateway, and here we're going to build the internet gateway. Okay. All right, so now we're going to build the routes. So the routes are really important. It's how we're going to get how we're going to associate our private app subnet to be able to hit that NAT, and our internet gateway to hit the, or how the public one will hit the internet gateway, and the private will just be able to connect to any resources that we want to allow it to. We're going to make some assumptions here and pretend that we have our transit gateway connected to on premises with a certain CIDR, and we'll define that CIDR as we get into it. But that is just obviously not going to be the case here, but we're going to go through and pretend, because this is a common use case. So let's start here. So resources, here we go with resource. So this is going to be an AWS route table. And we're going to name this RT public. So this will be our public route table. So the public route table is going to be, we're going to give it a VPC ID. It needs that. AWS VPC main. There we go. .id. And we're going to give it a route. So the route, here's how you define routes. Route, you give it a CIDR block, and in this case we're going to use 0.0.0.0.0/0. This will go to the internet gateway. That's what we want it to do. So give it a gateway ID, and it's going to be AWS internet gateway IGW .id. And there we go. So that is a route in Terraform. It's just like that. Pretty simple. And our second thing we'll do is we'll route. So by default, this route table is going to have the CIDR that we've already defined. It's going to have the 10.200 already in there. So these are just additional ones we want to add. It knows about the VPC. It knows that. So what we'll do here is we'll say, let's say we have another route. And this route is going to be on our on-premises. So what we're going to do is say a CIDR block, and we're going to give it like a 10.2 10.0.0/16. So this is our made up on-premises VPN connected system. So if this was the case, then here's what we would do. We would use the gateway ID, and then we'd use the transit gateway. And that's going to be var dot transit gateway ID. So that's our gateway ID. So there's our public route table. So straightforward, it already has the 10.200 addresses in there. We're going to add the CIDR block to go to the internet gateway because it's a public subnet. That's what makes it a public subnet, having a route out to the internet. And the CIDR block here is going to use the transit gateway, which would have a route, if this was really set up like this, back to the on-premises server. Right now it doesn't, and this will be black holed really, but that's fine. That's just an example of how we would set up a route in Terraform. Okay, so that's our one table. And what we're going to do next is we're going to have to associate that right to our subnets. So we go resource, and this is going to be an AWS route table association. There it is. And we'll call this just public. That's fine. That's good enough for us. Let me scroll down a little bit just so we can see the whole thing. Okay, so resource public. So what we'll do is this is for a few subnets. This could be as many as we have defined in our variables. Right now we have 2, so this will be a for each, and we're going to do it for var.public prefix. So we're going to go through each subnet and associate it. So subnet ID is going to be AWS subnet, and we're going to look for the public subnets, and what we'll do is each.key.id, and then the route table ID. So we're associating in this code block the subnet ID. We're going through, and every public subnet is getting associated to this route table ID. So it's going to be the same route table for each of these subnets. And it's going to be AWS route table. And you can see right there, RT public comes up. That's the one we want. That looks good, and it's an ID, so .id. And that's it. So there, we've created the route table and we've associated it. Perfect. Pretty straightforward right there. So the next route table is we're going to do the DB route table. So this is going to be even simpler, right? This is going to be quite simple. Let's just copy this actually. We'll just do the same thing we just did. We'll just copy this block, because this is not going to be much different. The only thing is we don't have we're not going to route this out to the internet. So route private data. That's what we'll call this one. And we do not want to route this out to the internet gateway because it's a private, so it has no route out to there. The only route we want it to have is to our on-premises, our fake on-premises CIDR. So there it is. That's it. And then the next step would be to associate, right? So private, call this, instead of public, we'll call this private data. And then we're going to go for each private. So this is going to be the private data. var dot private data prefix right there. AWS subnet, and we've got to fix this. Let me just get rid of, well, can I just do this? Dot private data prefix. Or no, this should be, what should this be? Private. This should be actually private dash data. This should be our subnet. So AWS subnet, let's see what we called it up here. Private dash data dash subnet. So it doesn't, it's not coming up in the, well, I think it would. AWS subnet private dash data subnet. Okay, that should do it. Each.key.id, and the is going to, it's going to be tied to the private data. That's right. Private data dot ID. All right, so there we have our private data one, our private data. Now the more complex one, and this is where we're going to get into some, this took a little bit to figure out. This was not as easy or straightforward as I was hoping it would be. This is going to be the toughest one, right? So we'll call this one. And the reason is because we have to tie these together, or we have to point the private to the public in the same AZ. So remember, NAT gateway is in a public subnet. So this route from our private app subnet has to point to the same AZ availability zone in the public. So that's why this gets a little complex, and that's why, as I was talking about before, in the variables we defined index 1, index 2, and you'll see, you're going to see that right here where we create this. Okay. So this is going to be resource, and this is going to be again an AWS route table, and the name of this is going to be rt-private dash app is what we'll call it. Okay, so our first step is going to be to do a for each. So we're going to do a for each here. var.public prefix. All right, so you might be saying, we're in the private app, why are we doing the public prefix? And I'm going to explain that. As we go along. VPC ID. Let me just make sure we did that on the last one. I think did I not put that in on the private? I don't think I did. Okay, let's just go back here. What we have to do is just add VPC ID equals AWS VPC main VPC, because that's what we're tying this to, .id. So that's, I need that. I almost forgot that. That's been added. Okay, I'm going to Control S just here. Let me go back down here. VPC ID equals AWS main VPC dot ID. Okay, that's always going to be the first that associates this route table to that VPC. Okay, now let's get into our routes here for our NAT gateways. So the first route, and I'll show you this route. So this is going to be pointed to our NAT gateway. So the CIDR block is going to be the 0.0.0.0. This is saying anything. And we're going to point it to NAT gateway ID equals AWS underscore NAT gateway dot NGW, right? NGW, and we're going to do each dot key dot ID. I've got two equals there, so let's get rid of one of those. Okay. So there you can see it, right? Because we know that the NAT gateway is in a public prefix, so it's going to use the correct gateway ID, the right NAT gateway ID based on that. So it's going to create two route tables, basically. That's what we're doing here. And what I'll do for the second route, I'll just copy this. Because remember, in all this routing, we're imagining that we have an on-premises over VPN at 10.2.10 connect to the transit gateway. And it's going to use that for our transit gateway ID to point all that traffic over to there. So any outbound traffic is going to the NAT gateway in this route table. Two route tables will be created, and then what we do is, like we do all the other times, we associate. So let's do that. Then, so the resource here is AWS route table association. There it is. And we'll call this one private app. So there we go, we've got that. So this is going to be a little interesting. So we're going to do a for each. So this is the only one. The other two, the public has one route table and the private data has one route table because it only needs one. This one actually needs two because we're creating two NAT gateways, and the NAT gateways, each AZ should have its own. So that is why we need to do this. So this is going to equal var private app prefix. And then we're going to go into subnet ID equals AWS underscore subnet dot private app subnet each dot key. So this is saying each one of our subnets dot ID, each of our app prefix private ones that we've created, we want to use those private app subnets and go through those. So that's going to be the two subnets. Perfect. Okay, so then the route table ID, we also have to define that, right? Because we're connecting a subnet ID to a route table ID. So this is going to be AWS route table RT private, that should be private app, whoa, private app, and then what we're going to do here, and this is the interesting thing, we're going to do public app sub dash AZ and then dollar, because we're going to use a variable here, each dot value, and we're going to use IDX, that's our index that we're using, and then we're going to go all the way out here and we need the ID, so dot ID of all that. So let me explain that, because this took some time to figure out. What we're doing here is we're doing the route table for RT private app, right? We're going through each one of those, but we're taking the public app sub dash AZ, which is the created public subnet. So I think that's in the variables, right? So we're taking this public app sub dash AZ1 and we're getting this index. So that's what we're doing there. We're grabbing that index. Let me go back down. So we're going to get the right one, each value IDX dot ID. So we're getting the right private app. And that's going to bring us, that's going to combine the correct one in each AZ to the correct route table. So it's a little complex right there, but it does work, it makes sense. So let's actually, at this point, do a Terraform plan and see what we have. So it does not like on step 131 or line 131. What doesn't it like there? VPC IP, right? Because I haven't saved this. Control S, that's the point. You must save it. Let's try it again. See if we fix the problems, and we have. So 22 things to add here. So here's the VPC, public subnet will be created, public subnet. Let's look for our route tables. So here's our route table. Route table associations, private data, public, public, and private app right here. And a route table association, and here, and this is pointing to TGW. This is my routes, route table associations, yep, routes. So this video is going a little long, so I think we'll stop right here, and in the next video what we'll do is we'll start with running this, seeing how this turns out and see how it looks, and making sure it's everything that we want it to be, and then we'll continue on into creating resource shares and then sharing it out to the prod VPC. So thanks for watching. I appreciate it. And I hope you enjoyed it.